In this example, we're going to discuss the amount of work done on a car being pulled by an elephant. They tell us in the introduction to the problem that the mass of the car is 500 kilograms. The coefficient of kinetic friction is 0.15. The angle between the rope and the horizontal is 30 degrees. The force of tension in the rope is 6,000 newtons. And the distance the elephant pulls the car is 100 meters. So we'll draw a free body diagram to get where all of our forces are. Okay, and then it's more useful if we take this angled tension and break it into components. So we still have mg downward. We still have force of friction resisting. We still have normal force up. But now we've got these two pieces of force, which are these components right here. There's an angle in there. Alright, so we end up with t cosine theta, and you know with t sine theta. Alright, and they ask us in the first question, what is the work done by each force acting on the car? Well, we can go ahead right now and say that the work done by gravity is 0 joules, because it is perpendicular to the motion. It doesn't contribute to the motion, so it doesn't add any energy. The same thing for normal is 0 joules. No need to calculate those. Alright? If they're perpendicular to the motion, form a 90-degree angle with the motion, they produce no work. So we're only left with force of friction and the tension. So the work done by the tension force is going to be force times distance, which in this case is going to be t cosine theta times our distance of 100, which is going to be 6,000 is our tension, times cosine theta, which is cosine of 30, times 100. And when we calculate it out in the calculator, we get 519,615 joules. The amount of energy transferred from the rope to the car. So that work done tension force on the car of the tension. We calculate the done by action. Calculate force of them. So we know friction is equal to mu normal. In this case, the force is just m this t theta acting forward direct. A little here we get all the forces normal plus t sine have to balance out all downward force with gravity mg. Means that normal must equal t sine, not t sine right side. Maybe really quick. Alright, equals m minus time. Moves it over. Alright, so we normal weight it out. Plugging 500.81 6,000 sine is equal to 1,905. So 1,905 is our force. Now when we force a friction, we have 0.1515 is our coefficient times normal force 1,905, which gives force friction of 285.8 force of friction. Now we back over work equals distance. Work equals negative 285.8, and negative because distance x to the right friction oriented friction. One of them has initial friction. Get work give to a give because in out some adding friction this, so they could have nominal is net total on the object. Get the work. Alright, we have all the work in minus all the work. In case we have 519,615 joules in, and we have 8,580 joules out. This was because of the friction this much sliding the ground. Alright, subtract we end up with 491,005 joule of energy is at the elephant this much and remove much. And that answers the first question, which was done by E4 car. Now asks how far the car will the elephant cut loose. Let's draw our free diagram with the new situation. In the situation, longer from the elephant. The forcing on the car now. Normal up, grab down, friction acting against the car. So we want to know how it can take come to a stop. Well, car starts this much. It starts 191.035 joules. That much. So we need to how far it go for friction to remove all that energy. So this would be done by done by we know is going to be the one by has to be negative 409,030.03 joules. Because that much energy friction remove for the come to a stop. It's going to be the friction. That's going to equal to force. Solve. We end up the work with 491,035. Okay, that's negative work, and friction is in a direction. So it's UMG. MG. This force tension is longer because the elephants. So the normal is now gravity. Friction negative pointing negative. R is moving. Velocity is to right. Is to left. So negative work and negative force. Negative 4.1035 equals 0.15 times r of 500 g. And this whole time I let it's the friction times distance, the friction times distance, and the friction times distance. And that's looking for how far the car went to come up. So we divide with a distance of 600 and meters. That's how far we'll go along thing to us because friction sap all the answer.